All right, let's, oopsie, sorry, I dropped it. Let's go ahead and finish out this section with some more conversions and applications and a summary. So, or a few remarks. Convert 3 miles into feet. Write the conversion factors you use. Okay, this is straightforward. This could almost have been an example 1. I'm looking at this. Okay, here we go. 3 miles into feet. Starting with 3 miles as our whole, making sure not to label it 3M because M stands for meters. 3 miles is our whole. And miles into feet. I feel like we only need one conversion factor. Each mile is 5,280 feet. Okay, so the conversion factor or the unit ratio we're using here is in purple. Each 1 mile is 5,280 feet. Got it. If I convert that, it looks like I'm doing 3 5,280s to make 15,840 feet. Got it. Convert 15,840 feet into yards. Okie dokie. So now we're starting with that. So 15,840 feet is our whole, and into yards. There are 3 feet in each yard. So in each yard there are 3 feet. There's my unit ratio and my conversion from feet into yards. And it looks like, I'm dividing. Well, actually, if I divide by 3, I think I'm going to get 5,280. But my label is yards, not feet, because remember, 5,280 feet is yards, but I'm going to double check because I feel awkward about it. Yep. Okay, convert 3 miles into yards. Okay, so 3 miles is the whole. Conversion factors. Miles. So we would still have to go through the same process. Miles to feet, feet to yards. But now, instead of doing it in 2 problems, we can do it in 1. So, 3 miles. In each mile, there are 5,280 feet. And then, each yard contains 3 feet. Okay, so there are the 2 conversion factors. And 3 times 5,280 is 15,840. I would have yards in that numerator. And 1 times 1 times 3 is 3, and I would have no units in that denominator. Feet, yards. Okay, and that ends up at the same result. Okay, 5,280 yards. And I think the point here is that every problem that needs 2 conversion factors, you could do as one big one, or you can do them as separate separate steps. So you can take each problem and either break it down into 2 problems or however many conversions you need to do, that many problems, or you can do it as one big thing, keeping tabs on all of your units. How many cups? So if you didn't like this, maybe you would prefer it like that. And if you get tired of doing it like this, maybe you would prefer to, synthesize it into this. How many cups are in a 2-liter bottle of Dr. Pepper? All right. What did it say? How many cups in a liters? Cups. I see that we can go to cups and to pints. Let's see, liters. I see liters down here. We can go liters into gallons or liters into quarts. How many cups? So, and then up here we can go from, cups, okay, ounces, cups into pints. Oh, okay, here we go. We could go from liters into quarts, and then quarts into pints, and then pints into cups. How many is that? I'm gonna put, you know what? I've used asterisks a lot. I don't know. I'm gonna use a diamond. Why not? Liters into quarts, or by the way, liters into gallons, because that's one more step though. So liters into quarts, and then quarts into pints, and then pints into cups. Okay, I see 3. We're going to need 3 unit conversion factors. Okay, let's do it. Okay, we're starting with a 2-liter bottle of Dr. Pepper. 2 liters is our whole. And then, first conversion factor. There are about 1.06 quarts in each liter. Ooh. My garage door just went up. That probably means my kiddos want to ride their bikes. Anyway, and then we said that once we are in quarts, each quart is 2 pints. So 2 pints in each quart. And then we could go from pints into cups. So what did it say? 2 cups in each pint. 2 cups in 1 pint. All right. I think we're ready. I see 2 times 1.06 times 2 times 2 in the numerator. And just to look at the units here, liters are gone, quarts are gone, pints are gone, cups are left. Yay! And then our denominator is 1 times 1 times 1 times 1. This was cups. 1 times 1 times 1 times 1, which is 1. All right. Calculators are made for. I see 2 times 2 times 2 is 8. 8 times 1.06. Oh, but we are going to have to label this with an approximation because this was an approximation. I remember that. Right there. Boom, boom, boom. That's an estimate. So approximately 8 point. You know what? I might as well round. It's 8.48, but 8.8.5 cups. Voila, 8.5 cups in a 2-liter bottle. A server serves 12 points to his or her or their patrons. How many gallons is that? Oh, pints and gallons. All right. Pints to quarts, quarts to gallons. 2 factors. Okay, let's rock this. 12 pints is the whole. And then from pints, we could go to quarts. Each quart is 2 pints. And then from quarts, we can go to gallons. 1 gallon is made from 4 quarts. Okay, let's do it. Make sure all of these units are correct by doing cancellation. That means we will be left by 12 times 1 times 1 makes 12 gallons. Split among 1 times 2 times 4 is 8. Okay. That is simplifiable. This divided by 4, so scale the numerator down by 4 and you get 3. Scale this denominator down by 4 and you get 2. That's 1.5. 1.5 gallons. 12 points, 1.5 gallons. According to the Counterfeit Detection Act 1992, people can make color copies of U.S. currency as long as they are smaller than 75% of the original size or bigger than 150% of the original size. Write the fraction form of the scales used to test dollar bills. Okay, that means we're going to need a big and a small. So let's go, I don't know, blue for big. So fraction form of the scales, 150% of the original size. So let's see, 150%. Let's go 150 fake compared to 100% real. Okay, so 100% reality to 150% fake would be our ratio here. I'm comfortable leaving it like that. Maybe we could write I'm scaling this down by 10. For every 10 real whatever, whether it's inches, centimeters, for every 10 real inches, make sure there are 15 fake inches. I can scale that down again. What? Divide by 10. So scale this down by 10. Make sure that for each 1 real inch, there's at least 1.5 fake inches. Okay, so there's our fraction form of how we would have to scale it up or down to get 150% of the original size. So this is the large or big, blue for big. And then let's suppose we are scaling down 75% or smaller. Well, 75 fake to 100 real. I'm just using that percentage. So remember, percent means out of 100. So, well, what is that? 0.75 fake for each 1 real. I remember now that I write this out, that I had students go immediately into the decimal form, but not realize how to put the fake in the real business. And some of my students went straight into this decimal form of 0.75, similarly. And then I had some students write this, which I was like, oh, yes, let's do that. So I actually learned this from my students through the semesters I've been teaching this class. And I kind of feel like this is the most intuitive way to look at it. But for each 1 real inch, make sure on the small end it's either 0.75. For each 1 inch, there's 0.75 inches or less. So let's put or smaller. And or larger. Yeah? Okay. An actual dollar bill measures 2.61 inches by 6.14. Okay. I'm going to draw this a little bit. Uh, 2.61 inches by 6.14 inches. Got it. If a copy is made with the dimensions of 1.8 by 4.3, is it against the law? Okay, now the first thing we need to realize is that this got scaled down. They've shrunk the money. So we do not need to look at the blue one. We need to look at the purple one. And okay, so they're shrinking it down. And I'm going to go ahead and shrink it down using this ratio. Okay, so here's my new one. It's a little bit of a shrink of the other one. And I'm going to go ahead and take 75% of these dimensions right off the bat. So I'm going to take 75% of 2.61, and I get 1 point, and I'm going to round down because I need it to be or smaller. So I get, so maybe I should write this down pretty quick. So 0.75, just to trace out my entire thought process. Boop. We're starting with 2.61 inches real. That's our whole. And then my conversion factor is 0.75 fake to each 1 real inch. Yeah? And I went bam, bam. Fake inches. So 75% of that was about 1.95. Okay, it really was 1.9575, which would normally round to 1.96, but if we did that, we would definitely get snagged as like a, that would alarm the bells in the counterfeit line. I don't know, what is that? Secret Service, I think, does counterfeits, checks for counterfeits. 1.95 inches. And then similarly, I'm going to scale this down. And I get 4.6, and I'm going to round this down, 4.60 inches. Okay, so this is an OK imposter, and ours, the one that was made, is 1.8 inches by 4.3 inches. It is not against the law because the fake one is or smaller. So 1.8 inches by 4.3 inches is okay. Show how you can tell. Well, it's smaller than the one that is an okay fit. I remember another student of mine, so just to bring back, during the class said, okay, but I didn't do that. What I did is I took the ratio of the fake one compared to the real one. So what did he say? He said 1.8 inches of fakeness compared to 2.61 inches of reality. And if you scale that down by 2.61, then this is approximately 69%. So it's okay because it's 75%. They are less than 75%. And so I said, absolutely, that is A-okay with me as long as you check each one. So he compared 1.8 inches to the 2.6, right? And he compared the 4.3 inches to the 6.14. And both of those had to have been less than 75%, and they certainly were. Okay, so there are more than one way to answer this problem, but you know, it's good. What are the smallest dimensions that are legal if we want to make prints? Oh, well, luckily we actually already did that. So I'm just going to put an arrow here and say 1.95 inches by 4.60 inches or smaller. Oh wait, is this for the big one? Larger. Oi, oi, oi. Okay, my bad. We're going to have to scale it up. That would be if we scaled down. Okay, my mistake. Whee! It says if we're going to go larger. Okay, let's make the bigger size one. But I'm going to use the same philosophy. Okay. So here's our real. That's a little bit really big. Here, when we were scaling down, we multiplied by our 0.7 fake to real. And now we're going to do the same, but we're going to be multiplying by the 1 point fake to real. So 2.61 times 1.5, and I get 3.9. And now I'm going to round up because it's this, and you need to be safe, or bigger. So 3.92 or bigger, and 6.14 times this 1.5 fake to real ratio, and I get 9.21 inches, or bigger. Okay, so here is the smallest they can be if you're going to increase the size. Okay, this drives me nuts. Yep, mistakes, they happen in math. Look at all the white out today. What are you going to do? Price you pay for writing in marker, yeah, instead of in pencil. So let's see, did we answer the question? What are the smallest dimensions that are legal if we want to make prints of dollar bills larger than they actually are? Here's the smallest size. Make them that or bigger, and you'll be fine. Okay, so what we just did is we did a ton of scaling up, scaling down, and sometimes that was in the conversions and sometimes it wasn't. So let's write all of that down. Scaling, making every measurement proportionally bigger or smaller. So scaling to me is making every measurement proportionally smaller or larger. Yeah. If you're going to scale a picture, then not only should you scale like the entire size of somebody's head, but you should scale their eyes too. So otherwise things get really weird. So make sure when we're scaling something, every measurement is proportionally smaller or larger. Okay. And then a couple of remarks here. First, be sure to write down any ratios you use or need along the way with their labels. Okay, so be sure to write all ratios along with their units. Needed. I'm going to call it needed to convert or scale. Yeah? I consider converting a scaling. Sometimes you're scaling up, sometimes you're scaling down. And another remarkable thing about these conversions is that these ratios, they are tools. So ratios, and I would say a lot of times these are unit ratios, but ratios are, yep, short and sweet. But it's really important to know which tool to use. Like, you can't build something without, the right tools. The act of canceling labels keeps track of each computation. So I'm going to write that down. So the act of canceling labels keeps track of each cancellation. I have a lot of students who are like, oh, I just forgot to do that one last one. Or, but I also, so this, it helps us keep track of those. But in addition to that, I also think it helps us keep track of whether we're supposed to be multiplying or dividing, which is the number one question I get from students during this section. Okay, so as a quick summary, conversions. So we didn't quite hit this quite yet. Did I skip an example? Oh, that's going to happen in the next section in 2.5. So it looks to me like this was actually, we did a lot of scaling, but really we didn't do that. Yeah. So we converted and we scaled one-dimensional measurements. And sometimes they were money and sometimes they weren't, but all of these scaling came down to making sure that we were making everything proportionally larger or everything proportionally smaller. And sometimes all you need is one conversion and sometimes you need 3. So for instance here, sometimes you only need 1 conversion factor or unit ratio, and sometimes you needed 2. I mean, sometimes you need more. But basically at the end of the day, your job is, and sometimes is to make sure that you have the ratio you need. Like here we actually even had to come up with our own ratio, and then following these steps will really help you ensure that you're doing it correctly. Label, label, label. Everything is all about units. Things change if you get your units wrong. Okay? All right. Happy scaling.